Okay, great. Thank you for your feedback.
Thank you, Vanessa. I will start.
Okay.
I am Sergei, editor-in-chief of refindustry.com website. Welcome to our webinar, Refrigeration Industry Innovations. Today, we will talk about the latest refrigeration technologies. Vanessa, my colleague Vanessa, will be the host of our webinar. I'm glad to welcome her.
Thank you very much, Sergei. I'm very glad to be here. I'm communication and event manager of the Ref Industry website, and I'm very glad to be here. I will be helping our speakers and our participants so this webinar goes well for everyone. And I think we can we have introduced ourselves, and we would like to know more about our participants. So those who have already connected, please write in the chat where you're from, maybe the city, the country, maybe even the company, as much as you would like to share. We would really like to know what kind of geography you have today. Saudi. I am from Frick India Ltd India, HP Products. From Denmark. Hello from Greece. Manila, Philippines. Hello from Italy. Great.
Switzerland. Great.
Yes, Switzerland. Yes, representing digital controllers. Hi from Spain.
Hola.
Philippines again. Andreas. Oh, the chat is going so fast. I can't read all of them.
All countries worldwide.
India, Turkey, Denmark, Thailand. Great. My dad lives in Thailand. Emerson, Romania. Arab Emirates, United Arab Emirates. Qatar. Interesting. So there is a big geography here. So I think we can start. We have got a lot of answers, and I'm very happy to give the word to Sergei.
Thank you, Vanessa. Greetings, friends. Welcome to our webinar. Today is 16th of June. The World Refrigeration Day is coming soon. The day shows how refrigeration technologies are important. How refrigeration industry, the cooling industry, make the people's life better every day. Cooling matters. And each of you makes life better worldwide. And we, refrigeration industry team, help you to make life better. So feel free to ask us any help and share your ideas, how we can help you to make life better every day. So thank you very much for your attention, and special thanks to Stephen Gill, who created and promotes the World Refrigeration Day. And I am pleased to introduce our great guests, our great speakers. Vanessa, please help me.
I would be really happy to help you, Sergei. Thank you very much. So our first speaker would be Francesco Faralli, Sales Engineer, Officine Mario Dorin.
Hi, good morning.
So then we will listen to Filippo Simionato, Technical and Sales Engineer at Hitema International.
Hi, good morning.
And our third speaker is Nikolay Koev from Sanhua Europe, Food Retail Market Manager.
Hello, everyone. Thank you for the invitation, and I'm glad to be here.
So it's great. I'm very happy to greet you all, and I'm very happy to greet all our participants. We already have a lot of people watching and listening to us. So I think we can start. And the first presentation will be from Francesco Faralli.
Okay, let me share the screen. Okay, so I will give you just a brief introduction on our compressor technology for transcritical CO2 compressor for industrial refrigeration. So first of all, just a quick introduction on our company. This is our company profile. Our company invested quite a lot in solutions with natural refrigerants like CO2 or hydrocarbons. And as you can see, we are still the sole company producing two-stage transcritical CO2 compressors. It's been more or less 30 years that we are developing compressors for transcritical CO2. 94% is our turnover growth in the last 10 years. 102 is the largest transcritical CO2 compressor available in our product range and also in the world. The company has been founded in 1918, so it's a 104 years old company. It's family owned. Dorin is the surname of the owner. We are 150 employees. All our compressors are produced in Florence, in Italy. And this year, you see, in 2021, we produced 77,000 compressors. So this year, we will increase that number by more than 80,000. In 2021, CD600 range, that is the largest transcritical CO2 compressor range available in the market, win the AHR Expo Award for the most innovative refrigeration product. So speaking of CO2, as you all know, when we speak about the subcritical CO2, the pressures of the system are more or less closer to other HFC refrigerant, like for example 410A. But when we speak about transcritical system, where the pressure of the system can go up to 110, 120 bar, obviously the working condition of the system, and in our case of the compressor, are much more severe, because we have larger stresses on the mechanical components because of the larger delta P. And also from a lubrication point of view, obviously it's not the same as Freon compressor. That is why we have decided, as I said, now it's been 30 years ago, we have decided to design a compressor from scratch. So not to adapt an HFC compressor for CO2, but to think of a new kind of compressor specifically designed for transcritical CO2. And today, that is the core of the presentation, I will show you just a brief introduction of all the technical details and technical features of our transcritical CO2 compressors. So the most important aspect for sure is the external discharge manifold that lowered the heat transfer from the hot gas discharge flow to the oil. This is for sure also one of the most recognizable aspects of our transcritical CO2 compressors. These compressors, depending on the application, can work with the POE 85 or PAG 68. The maximum discharge temperature sensor is set at 160 degrees Celsius. We have cast iron pistons instead of aluminum ones, like for HFC. We have for the models with oil pump forced lubrication up to the piston pin. That is one of the most stressed part in the compressor. All our motors are F-class insulated, meaning that they can work up to 155 maximum peak working temperature. And that is why all our compressor can also work with inverter between 30 and 70 Hertz, depending on the application. We have introduced on our CO2 compressor a patented oil containment system on the shaft that is able to reduce the oil carryover by almost up to 80%, depending on the working condition. And actually, this patented oil containment system has been also introduced after the CO2 range, also on our ATEX range for hydrocarbons, and in the end, almost 2 years ago, also on our standard HFC compressors. And the last row is are the values of pressure. So we have 100 bar standstill pressure and 150 bar maximum discharge pressure. If we speak about the crankcase of the compressor, and instead of using gray cast iron like for HFC compressor, we are using ductile cast iron. That for sure is much more expensive. It's roughly 50% more expensive than the standard cast iron that we use for Freon. And it's also not too easy to be machined like the gray cast iron. But on the other hand, it's quite strong and can withstand the higher pressure of transcritical CO2. Then, speaking of our CO2 design, as I said, one of the most important aspects is the discharge manifold. So here we see our design for transcritical compressor and the standard design for HFC compressor. That is also the same design used by all our competitors for transcritical compressor. So in case of transcritical CO2, we can go with the discharge temperature up to 160 degrees Celsius. And in yellow, you see in the picture the oil in the oil sump. So what happens is that with our design, all the discharge part is well above the oil, and it's also external to the compressor crankcase structure, meaning that this hot gas will not heat the oil. And heating the oil is quite, let's say, a dangerous problem for CO2 because the discharge is very hot and you risk to have a very high oil temperature. And of course, if the oil is very hot, the viscosity will drop dramatically. And in case of poor viscosity of the oil, you risk to have a lubrication problem. On the other side, you see that Freon compressor and also all our competitors have an internal discharge manifold. In this way, for sure, there is no separation between the hot gas discharge and the oil sump. And what you risk to have is that basically an higher oil temperature. Here is an example that we have made in our lab. We are working at 30 bar suction, meaning -5 Celsius, 100 bar, so it's transcritical condition. And the discharge temperature in this case is 113 degrees Celsius. What we have seen, we have tested a compressor transcritical with and without the external discharge manifold. So the oil temperature with the external manifold is 55 degrees Celsius, while with the internal manifold is 70 degrees Celsius. So it's 15 degree oil temperature, lower oil temperature. So now I'm going to ask a question to the audience, just to check if everyone is listening. And the best, that's not the best, but the quickest person to answer will get a prize, which will be most probably some Dorin gadgets. So in your opinion, just 15 degrees Celsius of temperature in the oil, how much will decrease the viscosity of the oil in this case? This is the question. So we go between 70 to 55. So the oil is a little bit more cold. And in your opinion, what would be in percentage the drop in viscosity between 55 and 70? Like, I don't know, 10%, 20%, 99%? You can write the answer in the chat box, because I think that you are not allowed to speak during the meeting.
Shall I help you read the answers?
Okay.
So we have the first answer 30%, the second answer 18%.
Okay. So you were close enough, but with the external discharge manifold, the viscosity comes from 15 to 10. So meaning that if we have oil at 55, the viscosity is 50% higher, and this is quite important when we speak about compressors. Then we have cast iron pistons, and this is also a unique feature of our compressor compared to all our competitors that are using aluminum. So the idea is that since the crankcase is made of cast iron, and we have the same material for the piston, because for CO2 the discharge temperature, as I said, is very high, and so we have the same thermal expansion between the piston and the crankcase, and in this way we have the lubrication gap between the piston and the cylinder that is always the same. In other case, what you risk is that the piston made of aluminum will expand a little bit more than what the crankcase in cast iron does. And so the tolerances between the piston and the cylinder will not be as the nominal values. Then for the models with the oil pump, we have a new patented, as I said, oil containment system. And then I'm going to show you just a little bit more in detail how it works. We have Duracon coating on the bushes. All the connecting rods, the small hands, have white metal bushes. As I said, we have lubrication up to the piston pin. That is one of the most stressed part of the system. And the respin is made of DLC, and DLC means diamond-like carbon coating. And this material basically can work quite well even with poor lubrication. So even with very low oil or with oil with low viscosity, you will not have any problem of lubrication. This is how the patented oil management system works. So basically here I have a short animation. It's the red that you see here in the oil sump is the oil. So basically the oil is sucked from the oil pump and goes through the crankshaft. From the crankshaft goes through the connecting rods up to the piston pin. And in the end of the crankshaft, the oil goes back to the oil sump. So what happened with the previous design was that some oil was flowing from the bushes in these directions. And when the oil was flowing here, some droplets were nebulized by the rotor. And here the blue arrow shows you the suction flow. So what happened in the past is that we have some suction flow that was trapping some oil droplets, and these oil droplets were then transported to the cylinder and then leaving the compressor. With the new design that is quite a very simple design feature that locks the oil in this part, and it's like a barrier, and so the oil, instead of leaving from this side, is forced to come back 100% to the oil sample. We have started introducing this feature in our CO2 compressor, and then when we have seen that the results were quite impressive, because it's, as I said, up to 80% less oil carryover, we have introduced the same feature on our ATEX family and also to the standard Freon. Here is to summarize, this is the CD600, the largest transcritical CO2 compressor available in the market, up to 102 cubic meter per hour, 100 bar standstill pressure and 150 bar discharge pressure. The electric motor is 180 horsepower, and the maximum discharge temperature is 160 degrees Celsius. All these compressors are equipped with the technical features that I have explained before. And here is an example of CO2 in industrial refrigeration using the CD600. We have made a comparison between ammonia and CO2. So the first system is an ammonia system using a screw compressor. The cooling capacity are 300 kilowatt at -8 and 400 kilowatt at -28. The system A is with ammonia, system B and system C are with CO2. So system B is a booster flash gas bypass system using a 7 compressor, CD600 for the transcritical side and CD7 for the subcritical side, and system C is also made of CO2, but it's a booster system with parallel compression, so a little bit more complex system, but also a little bit more efficient. And this comparison was performed in Moscow during the year. This is the mean ambient temperature and the assumption we have made, so it's an air-cooled condenser with 2 Kelvin subcooling and 10K delta T at the condenser for ammonia and 7 for CO2. And here are the results with the life cycle cost. So the system A is the blue line with ammonia, and system B and C are more or less the same and are the CO2 systems. The assumptions we have made are 2,800 euro per kilowatt of refrigeration, assuming this is the cost of an ammonia installation of this size, and 165 euro kilowatt of refrigeration for CO2. Maybe the economic values for Russia now are no longer value, at least for this year, but because these hypotheses were made 2 or 3 years ago. But in any case, this is just to show you that for an industrial application, the initial cost of CO2 now, in some cases, obviously depending on the size, is even cheaper than ammonia. And in some countries, here the example was made in Moscow, thanks also to the very good COP of CO2 system, we have the life cycle cost of the system that is much lower for CO2. In fact, CO2 is starting from a lower point in year 0 at the installation, but also the gap between the CO2 and ammonia increases during the year because of the higher COP of the CO2 system. Here we have some info, let's say, on the system design. CO2, when we speak about compressor displacement, is more or less 9 times smaller than ammonia. When we speak about the diameter size of the liquid line or the dry suction line, CO2 is, thanks to the higher pressure, much smaller. And here is a system design comparison, generally speaking, on the installation. So if we compare the ammonia and CO2 for industrial application, okay, we have oil management that is easier for CO2 that can work with the POE and PAG thanks to the excellent miscibility with these oils. At partial load, since we have rack made of several compressors, we have the efficiency that is more or less constant instead of having a system with a single compressor working at partial load. We can do with CO2 very easily heat recovery because the safety class is A1, so it's not flammable and not toxic. And in case we have adiabatic cooling at the gas cooler, there is no need for any chemical treatments to the water. Even the size of the machinery room, in case of a 1.5 installation, is much smaller than ammonia. And finally, here some references, not just for industrial, but let's say some examples. The first one are all made in Russia. This is one of our customer, Elementum, that made 20 CO2 hypermarkets or logistic warehouse in Russia. These are just some pictures of some installation. This is a distribution center with a cooling capacity of 2.2 megawatt installed near Moscow. These are some examples coming from LinkedIn using our compressor. So the first one is a ski arena in Oslo in Norway, 3.1 megawatt with the evaporating temperature between -4 and -12. Or on the other side, the ice rink in Beijing during the Olympic Games that were using our compressors for the cooling. And these are not example of industrial installation, but I think that are quite significant because of the application. In this case, we have the first supermarket using CO2 in Middle East, and was installed in 2017 in Jordan. And the installer made a comparison between 404A, so the previous system that was installed there, and the new transcritical CO2 system during summer period. And actually what they have found out that even if the ambient was 35 during summer in Jordan, the mean ambient temperature, there is a quite significant benefit in energy consumption between CO2 and the old HFC system. And finally, this is the last slide, also to show that CO2 can work quite efficiently also in very hot ambient climate. This is a rack installed in Madras in India, in the Indian Institute of Technology. And we know from the researchers there that the system runs up to 46 ambient temperature without any issues. So this is quite an important installation showing that CO2 can easily work also with very hot ambient climate. Okay, this is it. Thank you very much for listening. And if you have some questions, please feel free to ask me.
Thank you very much for all this valuable information. We had some questions during your presentation. I can read them if you like. So the first was, if the external air temperature is plus 20 degrees Celsius, is the plant in transcritic or in subcritic field? Oh, we can't hear you.
Yes, yes,
yeah.
It's still subcritical. So at 20-degree ambient, yes, it will work in subcritical.
Okay, thanks. Here is another question. Have you ever considered cooling these compressors with liquid, for example, water, somehow similar to internal combustion engineers?
Let's say not because as of now the air is enough for our working conditions, and we see that even if we use, for example, we have some projects for high temperature heat pumps, and even in that case, in case we use the external discharge manifold, we are safe on this side.
Okay, great. Thanks. There is another question. So out of 77,000 compressors produced by Dorin in 2021, how many are for CO2?
Let's say I will tell you in the turnover, so not in the number of pieces. Turnover is around 30%. But you have to consider that it's quite new technology, and this 30% also you need to take into account that we are in many businesses like railway air conditioning or ice cream machines. So in that case, it's huge volumes for us, and it's made with Freon. But if you look at like some sector, supermarket in Europe, then this number is 100% almost. Let's say all the major OEMs are using CO2. Okay,
great. Thank you very much. And I want to remind our audience that you can ask questions during the presentations. We will have a small QA session after each presentation, and we'll have a big QA session at the end of the webinar. So please be active and ask questions. So, and I think we have no questions yet. If somebody has them, they can ask them at the end of our webinar. And then we can move on to our second speaker. So, and it will be Filippo Simionato.
Thank you, Vanessa. So let me share the screen with the audience. Okay. So some words about me. I'm Filippo Simionato. I'm an energetic engineer. Here in Hitema, I'm a representative technical and sales engineer. During this presentation, I want to share with the audience our new data center application series, DTS and DTSF, speaking about technical advantages, production and assistance advantages, and commercial advantages. Before starting speaking with this topic, I want to say some words about Hitema, who we are and our vision. So Hitema is a specialist manufacturer with over than 32 years of experience in the production of customized chiller and heat pump solution for process cooling and industrial comfort application. So we are present in 50 countries worldwide. This year we opened two new markets in Australia and also in Mexico. We have over than 30 ranges of product. All our products are future oriented, so we work to give the possibility to the customer to match all the refrigerant available in the market and all the possibility to make a customization on the unit. All the production is here in Italy, so we have 7 production plants, and the 95% of our business, of our market, is based on customized solution. But not only customized solution starting from the engineering, also customized solution starting from the frame, the cabinet of the unit. In fact, in our company, we have also our own carpentry, with which we can customize by the first start of the project, so starting from the cabinet, all the project of the customer. For sure, we have a production right now of around 1,900 units per year, moving from the little one of 1.6 kilowatt on the biggest one, water-cooled turbo-core solution that could reach up to 3 megawatt. The idea is also this one, so to follow the customer starting from the engineer and getting 100% satisfaction also with the post-sales, okay, and assistance, of course. In this way, we in the last 3 years, we also approach to the data center market. In fact, generally in this application of data center solution, in the past, customer looked for air conditioning application. Now we see since the last year that the market has moved from air conditioning to process cool solution. So customer required efficiency on the units, reliability, and customized solution. And this is why a lot of them starting ask to us to customize that solution. For this reason, we realized this new data center line of product. So the DTS is an air-cooled solution. DTSF is a free cooling solution. Of course, all these series, the trend, follow the trend of the next 5 years. In fact, we can have challenges in the market using a new refrigerant like olefine like R1234 Zeta E or YF, but also low GVP refrigerant that market allow us to use like R513A or R515B. Of course, this series born with screw or inverter screw compressor, but in the modular and back-to-back configuration, we can also move on turbo core or scroll compressor. Basically is based on high efficiency, possibility to have optimized free cooling, and as said, possibility to use also low GVP refrigerant. Generally, this series is born for data center application, but we can also see following and using and producing this unit that is also useful and available for several process cooling applications in the market. Moving from the technical advantages of this new series, first of all, having our own carpentry, an advanced compact design. So basically designing from zero the unit, so starting from the cabinet, we can reduce the impact of the frame and the impact of the design on the 100% of the units. Second of all, for sure, having this opportunity, so having also the opportunity to customize the unit, we have also the possibility to, on this series, to add pump or pumps and tank inside the cabinet, because we see that in particular for data center application, the required of an hydro module connected or related to the chiller or inside the cabinet of the chiller now is asked, but also give the opportunities not only to customize the unit using, for example, inverter compressor, so to follow the load that the customer need, but also adding inverter on the single pump or on the double pumps, giving the opportunity to the customer to follow better also the flow rate of the system. Of course, depending on the performance that the customer asks, we can also follow different field with this configuration. So if the customer is looking for efficiency solution, so look at the parameter like SEP, ER, okay, we can move of different kind of configuration for the condenser coil. So we can move with a 4+2 rows, 4 rows on the condenser coil and 2 rows on the free cooling, or standard configuration working 100% free cooling, so get more importance to the free cooling side with 3+3 row configuration, or the optimized version of the free cooling 2+4 rows configuration. Of course, as I said, all the series is designed to meet which is the new directive in the market. So to follow the ERP 221. Basically, this is done because the V-type condenser coil solution allow us to get more flexibility, so more reliability also on the use of the system. And of course, using in all our series EC fans with 800 or 910 millimeter diameter. This series, as I explained before, not only look for data center application, but is also designed for different markets. In this way, the DTS solution could be also think for different countries where there is a required of limit of refrigerant charge if a circuit. In particular, we design modular solution or back-to-back configuration using scroll compressor and low GVP refrigerant to meet the requirement, for example, of market like northern of Europe, Norway, Sweden, Finland, where the refrigerant charge asking for each refrigerant circuit is lower than 10 kilograms per refrigerant. In this way, in our DTS modular solution, we can reduce the refrigerant charge up to 8 kilograms of refrigerant each refrigerant circuit. Of course, designing a new series, the important is also to give for the efficiency of the unit. So have a look not only with our supplier of main components such as condenser coil or evaporator to get the best efficiency possible. This is why the approach, for example, evaporating side is 2.53 degrees, and the optimized condenser coil with 12 millimeter diameter tubes allow us to reduce the refrigerant charge, the possibility to use also microchannel condenser coil, and of course, reduce the approach condenser side to get the best efficiency as possible. Following the designing of a new series and following also the vision of the company, to design a new series is not only important to give importance on the technical department, but also on all other departments who follow that. In particular, with this new series, we have greater reduction on production time. So the installation of the condenser coil plus fan, so the castle structure is faster, but also we can improve the purchase department work because we move, for example, the cost to manage for the condenser coil from 12 to 2. So we reduce the time to get a better managing of the warehouse in this case. And of course, moving, for example, from an M-type condenser coil to a V-type condenser coil, we can also get faster assistance and spare part service on this chain that generally cause a lot of problem for the customer. Of course, this is one of the more important points because looking to this point, so on the assistance and on the spare part service, here in Hitema, we test all the units we produce. So we have a testing area with which in a single refrigerant circuit, we can test up to 1.5 megawatt each refrigerant circuit. So it is much more important this point, and give opportunity also to the post-sales department to get faster with the answer to the customer, because all the units could be tested and were tested. Last but not least, give the opportunities to the commercial department, okay, to keep in their hand a wide range of a series that cover a wide range of opportunities. Of course, this application designed for a data center not only look for data center application, but move and focus on the energy efficiency also on different operating conditions, but in particular different ambient temperature condition. Our units, DTS and DTSF, are able to work up to -40 degrees of ambient temperature. So looking, for example, for Russian market, or are able to work up to 55 degrees of design ambient temperature. So giving the hand of the commercial department a wide range of opportunities, not only for the operating condition, for sure, also for the range of cooling capacity. With our range, we can meet from 250 kilowatt up to 2000 kilowatt of cooling capacity, designing in 2 or 3 refrigerant circuits. Now, for example, based on our philosophy and our mentality of customization, we are designing a 4 refrigerant circuit unit back-to-back configuration with 2 point of feeds, okay, working with 4 refrigerant circuit, and also staying in the 30 meters, okay, of length of the cabinet. Getting a conclusion, so following the market where the increasing price of raw materials and as a consequence of the main components of the unit like fan, condenser coil, evaporator, and so on, give in the hand of who have to sell and who have to propose this series the opportunities to get optimized version of the units at a reducing price, reducing cost than the previous series is important. And in this way, this new DTS and DTSF series can follow better, which are the requirement of the market that right now we are open to fight against. So thanks to all guys, thanks to listen me, and if you have questions, feel free to ask.
Thank you very much, Filippo, for your presentation. We are waiting for any questions you have.
Vanessa, let's give words to Radomir. I will try to know.
So, Radomir, we have connected you. You can ask your question if you have one. It seems we don't.
We have any problem with connection with Radomir. Let's go on.
Let's continue. Yes, okay. Okay, so we can move on to our next speaker, and it will be Nikolay Koev.
Thank you, Vanessa. Let me share my screen. Hello everyone once again, and welcome to Sanhua webinar, Sanhua presentation. I would like to thank the organizers, refrigeration industry, for the invitation to participate in this event and for the opportunity to present you our new electronic experiment valves and control solutions for refrigeration applications. My name is Nikolay Koev. I'm a food retail market manager EMEA at Sanhua International Europe. I'm located in Bulgaria, and I have 15 years of experience in the refrigeration and HVAC business. I will give you a short information regarding the Sanhua company. We are a global leading producer of components, controls, and heat exchangers. The company was established 38 years ago. We have 4 business divisions. The first one is HVAC and refrigeration. So we produce a variety of components for the refrigeration and HVAC industry, and we are the biggest supplier to the air conditioning industry. Home appliances, we produce many different products for home appliances, and we are the biggest supplier to the European OEMs. Microchannel heat exchangers, we have a production since 15 years of different types of microchannel heat exchangers, which are used in the refrigeration, air conditioning, and heat pumps units. We have more than 50% global market share. And the fastest growing division also for us is the automotive industry. We developed a very specific units which are used in the electric vehicles, such as thermal management systems, which are able to cool down or heat up the air in the saloon of the car, but also to cool down the batteries of the electric vehicles. In 2020, more than 23,000 employees and more than $4 billion turnover. Last year, we achieved a growth of 50%, so reaching $6 billion turnover. And moving to my presentation, I will start with some basic information related to the refrigeration systems. There are different types of refrigeration systems, but one which is mostly used for many years is actually the vapor compression refrigeration system. It consists of 4 mandatory components: a compressor, which is the heart of the system, 2 heat exchangers, a condenser, which rejects the heat to the ambient, it could be air or water or any other kind of fluid, evaporator, which absorbs the heat from the conditioned space, let's say cabinet or cold room, and expansion device. We've been witnessing a lot of improvements in last decades, which make the systems more complex from one point of view, but also more reliable, and what is the most important, more efficient. Such examples are, for example, compressors with capacity modulation, or with frequency inverters, heat exchangers, which are optimized heat exchangers with improved heat transfer coefficient, and also the transition from AC fans regulated by simple pressure switches to AC fans controlled by sophisticated controllers, and also different types of expansion devices. So today I will focus on expansion devices. So we will look at the different types, what are the differences between these expansion devices, and why the expansion valves is actually so important in order to achieve optimal energy efficiency in the system. So the simplest expansion device that I believe everybody knows is the capillary tube. It's a simple tube with a small diameter and certain length. Usually the capillary tubes are used in small capacity units with, let's say, constant heat load and stable working conditions. If there is a fluctuation in the working conditions, actually the system becomes inefficient. The capillary tube is not able to regulate the superheat. That's why the usage of the capillary tube is so limited. The most efficient and successful mechanical expansion device is actually the thermostatic expansion valve. It regulates the superheat on the evaporator and adjusts the refrigerant flow to the evaporator. Here we have also some limitations in order to achieve maximum energy efficiency, and it comes from, on one side, on the superheat, because the thermostatic expansion valves cannot operate at a very low superheat. Usually they have static superheat 5 or 4 kelvins. The set point is in most of the cases 7 or 8, and usually they operate at 10 Kelvin or 9 Kelvin, which means that you may know that the lower is the superheat, the more efficient is the system. And they're also limited in terms of pressure differential, which means that they cannot work, let's say, properly at a very low condensing temperature. And you also may know that the lower is the condensing temperature, or the lower is the ratio between the condensing pressure and evaporating pressure, the more efficient is the system. So the devices which are able to cover these requirements, work at a very low superheat and to work at a very low condensing pressure, are actually the electronic expansion valves. Here I will show you two types of electronic expansion valves: pulse-width modulation and stepper motor electronic expansion valves. The electronic expansion valves cannot operate independently, so here the controller is needed in order to measure the pressure and the temperature at the outlet of the evaporator and to regulate the superheat by adjusting the position of the electronic expansion valves. What's the difference between these two types? The pulse-width modulation valve, the working principle is similar to solenoid valve, so it is either closed or open. Here we don't have a continuous, let's say, modulation of the refrigerant flow, so it is, say, the 100% of zero. Also, these valves are very used, let's say, in the refrigeration business. I would say that the refrigeration business is dominated by the pulse-width modulation valves, but also there are some drawbacks, such as liquid hammer effect, pulsation in the valve, and also some noise generation. The most sophisticated electronic expansion valve is actually the stepper motor valve. Here we have stem, which is controlled, which is moved up and down by the motor of the valve. So the regulation of the refrigerant flow is very precise. Such valves have 500 steps, from 500 steps up to 5,000 or even 6,000 steps. So they're regulated very precisely by the controller. Why we don't see so many stepper motor valves in the refrigeration systems? I would say that there were some obstacles in the past. First was, of course, the price. This combination stepper motor valve and controller for stepper motor valve were a little bit more expensive than pulse. Also, stepper motor valves required additional power supply backup. And there was, let's say, an issue with the tightness of these valves. We at Sanhua have been working a lot in last years to improve also the stepper motor electronic expansion valves to make them more affordable, more reliable, and of course more tight. And nowadays we are one of the global leading producers of thermostatic and electronic expansion valves for refrigeration, air conditioning, heat pump, and automotive industry. And we see already a smooth transition also in the refrigeration business from pulse-width modulation electronic expansion valves to stepper motor electronic expansion valves. How we managed to make this happen and to make this solution affordable? It is a matter of economy of scale. We produce more than 40 million pieces of different types of electronic expansion valves, mainly stepper motors. As I said, we are the biggest supplier to the AC industry, where we have only stepper motor electronic expansion valves, and also to the heat pump industry. So we developed electronic expansion valves specifically for commercial refrigeration applications. Our model LPF, we have several modifications with different design pressure, 42 bar, 60 bar, and 90 bar. So LPF is applicable with standard refrigerants, LPF D, LPF T with CO2. What is specific for this valve? This is the tightness. So this valve comes with soft sealing design, which means that when the valve is closed, there is no internal leakage rate through the valve, and no need to use a solenoid valve before the stepper motor electronic expansion valve, as it was in the past. This is a unipolar stepper motor valve with 500 steps. And we have also a valve, DPFR, with maximum operating pressure 140 bar, which is applicable with CO2 transcritical condensing units. As I said, 90% or roughly 90% of the commercial refrigeration systems are equipped with post-heat modulation valves. So then the question is, if customers want to keep the control system, which is usually prepared to control the controllers for post-heat modulation valves, can control only post-heat modulation valves directly, and they cannot control stepper motor valves. Then what is the solution if the customers want to keep the main controllers but to use stepper motor valves? We developed a driver which is compatible with post-heat modulation, electronic expansion, EV case controllers. So it can receive 0 to 10 volt signal, and it converts this signal to some certain number of steps on the electronic expansion valves. So no need to change the architecture of the system, no need to change the control system. Just in order to control stepper motor valve, you need such simple driver. What is important to mention that this driver is equipped with integrated ultracapacitor, so no need to add additional power supply. We have also extra closing function, which means that at certain low voltage, receiving certain low voltage signal, the controller will close the valve completely and will add 10% more steps, which means that if the EV has 500 steps, actually the controller will add additional 50 steps to ensure that the valve is completely closed. Another very interesting and I would say elegant solution, especially for customers who want to improve, to upgrade their systems from simple thermostatic expansion valves and solenoid valves to electronic expansion valves, but they also want to keep the same control configuration, let's say simple thermostat case controllers, which usually measure the temperature and control the solenoid valve. Here we offer our superheat controller, which can be integrated very easily with thermostat case controllers, just receiving run signal and run the valve or stop the valve. These superheat controllers comes with advanced PID algorithm, so it can control the electronic expansion valve very precisely. We have 26 refrigerants in the database, so customers can select from very standard HFC refrigerants, some transition refrigerants like 448, 449, also some new A12 refrigerants like 455A, but also hydrocarbons like propane or CO2. Here we have also a communication port, so this superheat controller can be connected to monitoring system via Modbus. There are 4 operation modes. By default is the superheat control, but also this controller can be used as a driver. It has manual operation, or it can be used as a hot gas bypass solution. And our new flagship controller, it's called Secrevo. It is an EV case controller, which means that except the superheat control, here we are able to control all functions in a cold room or cabinet. Again, this controller comes with advanced PID algorithm with 26 refrigerants in the database and possibility to connect to a monitoring system. I will give you a little bit more information in the next slides. So let's look at the outputs and inputs. On the bottom, we have the possibility to connect to the electronic expansion valve for temperature sensors and the pressure transducer. Also, we have the power supply. We have the communication port, also the remote display, which can be used to monitor the temperature of the cabinet or the cold room, but also to make all the settings of the controller. These controllers can be connected in master-slave operation. And we have also digital input for dual temperature cabinet. So we have 2 set points. One can be, for example, medium temperature, and one can be low temperature. So the technician can switch between the 2 set points, depends on the needs. And on the top, we have output relays. to control compressor or solenoid valve, electrical defrost, fans of the evaporator, alarms, the lighting, for example, in the cabinet, and the possibility also to connect the supercapacitor. Here it's not integrated. We have a separated device which can be connected to the EEV case controller. In order to illustrate how this can be integrated in a real, let's say, supermarket system, I will show you the next slide. So if we have a supermarket with several cold rooms and several cabinets, then the EV case controller can be installed in the switchboard, and the display can be installed on the front panel of the switchboard. Then we have the electronic expansion valve, the pressure sensor, and the temperature sensor installed in the evaporator. These controllers can be connected via Modbus. And for the cabinets, again, the controller can be installed in the switchboard on the top of the cabinet, and the display can be installed on some visible place and accessible place for the technician also to change the parameters, but also the supermarket manager, for example, to check the temperature. If we have several cabinets, then we can use the master-slave option. So the first controller can be master and the rest can be slaves. So we can connect up to 9 slaves, so they can share actually the information received by the pressure sensor on the master controller. So it is quite a simple solution, but using this solution, actually, you can achieve the maximum energy efficiency, especially comparing to thermostatic expansion valves. And to summarize, what are the advantages using our electronic expansion valve and our EEV case controller? So it provides an extremely precise superheat control and refrigerant flow regulation, which of course results in a much better energy efficiency. With our electronic expansion valves, there is no need to use solenoid valves because we have soft sealing design and the tightness is similar to solenoid valve. These electronic expansion valves can work at a very low load, very effectively. And you may know that stepper motor electronic expansion valves actually consume less energy in operation comparing to pulse width modulation valves. What is important, especially for technicians who used to deal with different refrigerants, with different capacities, if they used to work with thermostatic expansion valves, especially now we see that on the market that a lot of refrigerants. I can say that the EV is universal solution. You can use the electronic expansion valve with any kind of refrigerant, and also the capacity of one electronic expansion valve is actually much wider comparing to thermostatic expansion valves. So one EV set actually can replace, I would say, dozens of different thermostatic expansion valves, which means that you can really reduce the inventory of thermostatic expansion valves. And last but not least, Sanhua philosophy has always been to develop a products which are user-friendly, which are flexible and easy to integrate in any system, but also to incorporate functions, especially in the controllers, which are useful, so the customer pay for functions they use and nothing more. So we don't incorporate some fancy functions which customers will pay but will never use. Supporting tools, you can find on our website a lot of technical information, data sheets and installation instructions, but also soon will be released our new online-based selection software. If you have some questions related to technical topics or commercial, you can check also the contacts on our website. You'll find all technical and sales managers for the different regions, so you can contact all people at Sanhua International Europe. Thank you very much for your attention. If you have some questions, I'll be glad to reply.
Thank you very much, Nikolay.
You're welcome.
So we're waiting for some questions. I can see someone is saying congrats, Nikolay Koev. So please ask any questions if you have them. And while you're thinking, I would like to ask Francesco to tell about the prize. Who did you choose? What prize are you sending?
Just 1 second, let me see, because in the chat was Miail Dan, that was the one that gives the answer closer to the correct value. So if you can send, I don't know, maybe to Vanessa your contact details, we will ship you the prize, that I guess are some gadgets, but I don't know which ones. But
Okay, yes. So please, Mikhail, if you hear us, if you're still here, please send us the contact so we can contact you with the prizes.
thank you.
So, do we have any questions? I think we can just wait for 1 minute if the audience has any questions. So I think we don't have any questions, and I would like to thank our speakers for your precious time and valuable information, which you have shared with us today. And a very big thanks to our audience. Thanks for being here with us and being active, asking questions in the beginning of the presentation. And we invite you to join the Global Refrigeration Directory. There are more than 100 leading refrigeration companies. You are welcome to add your company too. I will leave the link in the chat. So please, you are very welcome. I have left the link in the chat. So great. Thank you very much. We have come to an ending of the webinar. So have a great day.
You too. Have a great day too.
Thanks.
Have a nice day. Bye.
Bye.
Bye.